all. Today let's just talk a little bit about ARPA. So you can just get a general idea of how a ARPA looks like on the screen. So you can see it is a radar cum ARPA. When we say ARPA, it is not an independent equipment as such. So we know that it's integrated into the radar. So this is just one of the models. So just to give you an idea how a ARPA looks like on board. This is one of the pictures. So just have a look at it. So what is ARPA? ARPA, Automatic Radar Plotting Aid, is a computerized additional feature to the radar. We all know radar sends out pulses, reflects back from the targets, and it is presented onto the PPI, right? So then what does ARPA got to do with radar? Because we need the information of all the targets in the vicinity so as to take a proper action and get away from all targets nearby, or rather to avoid the risk of collision, we definitely need to take action. ARPA gives us the data about all the targets in the vicinity. So ARPA takes feed of our own ship's course, right? And the target scores and speed and calculates the collision avoidance data. It simplifies the need for the users to calculate the data themselves. That means, what are we trying to say? We're just trying to say that instead of doing the radar plotting, manual radar plotting, ARPA does the job for us. So being a small computerized feature, it has some additional features and controls as well. So what is the data which a target gives us so that we can take an effective action? So you can see range, bearing, CPA, which is the closest point of approach, TCPA, time to closest point of approach. It calculates the true course of the target and the true speed of the target, bow crossing range and bow crossing time. Now you can just have a look on the slide regarding what are the different data which is displayed on the radar screen. So you can see the range and bearing, the heading marker, the guard zone, the various other features like the EBL, VRM, the pulse length, the echo stretch, and all other features which a ARPA screen will give you. And you can see on the top right hand side corner the gyro. Here it says 132.7, that is the course of the vessel. So ARPA takes the course of the vessel, that is what I told you just a while back. And then the speed here in this display, it is taking from the log. And then just below it, you can see few particulars of the target number 1. So let's have a little bit blown up look of the same data. So in this screen here, you can see for target number 1, the range, bearing, course, speed, CPA, TCPA, BCR, BCT, the same data which you looked on the previous slide, but this is the information of the target number 1 on the screen. Similarly with all the other targets which is there. So let's just have some look how this radar plotting procedure, how is it done manually in case the radar fails. So own vessel is steering a course of 049 degrees at a speed of 12 knots. And let us assume that there is a target and then we are taking the bearing at distance of the target in regular intervals of time. So presently you can see here at 12:06 hours, the bearing was 095 and the distance was 10 miles. At 12:09, 090 and 8.5. At 12:12, it was 085 and 7 miles. And finally, we are trying to find out the data of the target at 12:12 hours. So this is the basic question. So let's go into seeing how to work this if suppose we have to do a radar plotting ourselves manually. So this is the basic setup. the course is shown 049, vessel steering 049 at 12 knots. So the bearing and distance at various times were given in the question at 12:06, 12:09 and 12:12. So taking the bearing and distance of the target, so we have started to plot. You can see a small star mark over there and it is named as O. From there we get to plot the position of the target at various times. So this is the second bearing and distance of the target. You can see by a second star mark, and finally you see the third position of the same target and we have named it as A. So first named as O, the third named as A. Basically we try to take 2 or 3 bearing and distances of the target just to make sure the target has not altered its course in between. We need the course and speed of the target, or we calculate the speed and course of the target also on the assumption that the target has not altered its course or altered its speed. So we join this line OA and extend it further. Now what does OA represent? See, our ship's course is 049 degrees. And what does this line OA represents? OA line, this represents the line of approach of the target. I hope you are slowly trying to understand what I am trying to say. I am not saying OA is the course of the target. I am saying OA is the line of approach of the target. Why? Because we are stating a course of 049. So relative to our course, we see the target approaching in the direction of OA. Next, I told you our course is 049, isn't it? So we transfer this 049 to the point O and extend it in the reverse direction. So just to make it very simple, you can add 180 to 049, 229 and draw it from O in the reverse direction. Now you may ask, I am steering 049. Why do I have to draw it in the reverse direction? The reason being the target has already moved from O to A. So we need to draw it in the reverse direction to complete the triangle and to find out the other features of the target. Having drawn this line which is parallel to 049 in the reverse direction, we know our ship speed is 12 knots and we have the plotting interval of 12 minutes. So our speed in 60 minutes is 12 knots in 12 minutes. So that plotting interval is plotted as the point W on the line which we drew reciprocal to 049. So the point W is marked accordingly on that line. Finally, we join WA. I repeat, we join WA. So what does WA line represent? WA line is actually the course and speed of the target, and the line WO represents the course of the ship or the own vessel, that is 049. So to sum it up, OA is the line of approach of the target, WO is the course and speed of own vessel, WA is the course and speed of target. So we extend this line OA past the center of the screen of the PPI and drop a perpendicular to the point C. So and we mark that point as N. So the distance C to N, that is the closest point of approach of the target, provided we don't alter our course and speed and the target also doesn't alter her course and speed. So CN is the closest point of approach. So then what is time to closest point of approach? So we saw that CN is the closest point of approach. So you measure the distance CN. So CN divided by OA into the plotting interval which was 12 minutes that will give us the TCPA. So we can see this CPA, TCPA, course of target, speed of target. So we are able to get these data of the target to take a relevant action for the target and avoid any close quarter situation. Now finally, aspect of a vessel is the relative bearing of own vessel from the target vessel. Or for you to understand it much simpler, you can imagine as if you have now, like a bird, you have flown away and now you are on the target vessel. Imagine that you are on the target vessel now. So from the target vessel, if you take a bearing of own vessel, so that angle will be the aspect. Aspect is a very important feature for taking action in a collision situation. So please do understand how this aspect will help us so that we can take an efficient action and do it also timely. Okay, thank you all.